Alright, welcome back. So this is the thing. Okay, so someone says this is true. Yeah, okay, great. What? Eh? Okay, so I mean, one's here, one's here. So for example, if n is a prime, it is literally true that you get like a bunch of ones and it's multiplied by p minus 1. So at least that much I can verify. I don't know how much more I can verify. What if n is like twice a prime? Then what happens? It's like then it's like 1, 2, 1, 2, up to and there's like a random p? And then it's like 2p or something? What? At least I know how to do the case where it's prime. If it's like... What if it's like p times q? So most of the things are still 1. If I still just subtract... Then if I still subtract the top row from the bottom row, it's like I get something weird like pq minus... Okay. So I actually need to... Yeah, so I really want to induct on n because, you know, things. So maybe the question is there a way I can... Is there a way I can actually figure out what these coefficients are if I want to multiply by... I want some linear combination of the rows t1 through tn minus 1 such that GCD of n comma k is equal to the sum... Like what combination of the things on the top gives the things on the bottom? Gives the bottom row. So for example, if n is prime, then it's really easy. You subtract the top row once. It's like 1, 0, 1s and then all zeros, and then you're good. What if it's something a little more complicated? What if I take the things that divide n or something like that? Hang on. Hang on. No. Okay, wait. I'm gonna actually just write it out for 1, 1, 3. I'm gonna write it out for 15 and see what the hell's going on. I might only need to subtract a few things. Maybe TM. 3. right? So if I subtract all ones and then... How would it get down to phi? Like, I wonder if I can... Like, the nicest thing that could happen is I'm subtracting all the... Right, so I have a row of all ones here. That's fine. I should only be subtracting, like, one from each. 1, 5, right? Like, there's some... I only need 3 rows, I guess is what I'm trying to say. Like, if n was prime, then I only needed the top row. If n is, like, say, 2 primes like this, I only need to pay attention to this row, this row, this row. The question is, like, what combination of rows do I subtract? And I bet it's minus, minus, plus, right? Minus, minus, plus. Oh, that's good enough. And then, you know, then you get 10, 7, 8, which is indeed the thing you want. Okay, so that works for 50. I assume this just works in general, right? What's the general claim? The general claim is that if I take... Let's say n is equal to, like, p1 to the e1, pk to the ek, then I claim that for all... What am I trying to claim? Okay, I mean, in this case, we know what the answer is supposed to work out to, right? So it's like p1 to the e1 minus p1 to the e1 minus 1. So you imagine this is phi of n. It's this product. You can expand it. And the claim is that it just works. I think it just works. Because you either get... Yeah. Mobius. Thanks. Yeah, thanks. Oh, is it just Mobius? Wait. Oh, so... Wait, I would have thought it was like Mobius of n over d. Or something like that, right? Because if I have like a fact... Like, suppose like 9 divides n, right? Then I actually need to... filter the 9 more strongly? Is that true? Yeah, Mobius n over d. Yeah, but then it should be fine. In fact, does this just follow from, like, convolution stuff? I don't... Okay. Claim sum Mobius n over d GCD m k across d dividing n. For all fixed m. Well, okay. Yeah. If I have a fixed m, can I nuke this with like multiplicative? Hang on. Sorry, this doesn't even type check. This should be m comma d, right? Yeah. I mean, this should just be true, and just like you just factor it, right? Like you just straight factor it. Right, because for fixed m, GCD of m comma, this is multiplicative, right? Maybe we can even, if I'm being tongue-in-cheek, I could call this like G sub m, which is the worst notation ever. But then the point is that this is a convolution. This is a convolution of mu and g sub m. And again, m is fixed. Wait, something's not right. No, no, no. I'm tripping. Wait, no, what? Hang on. Are you sure this is right? Because the right-hand side is not a multiplicative function, right? I mean, it's literally... Did I get the claim right? Wait, this is a... No. So for fixed m, this is a multiplicative function. So I feel like the left-hand side should be a multiplicative function, but the right-hand side isn't, so I'm messing something up. Right? No, but even for a fixed m... Like if m is like 6. What am I doing? Like, this thing is multiplicative, right? This one should be because, I mean, it's just... If A and B are Yeah, so why am I tripping? Oh, is it actually multiplicative? I feel, because if m is like 6... For example. Oh, actually, yes, no, it is. It should be okay. Yeah. For the data that I have, if I take two things, oh, okay, never mind. Yeah, okay, maybe it's just fine. Never mind. Yeah, so then it suffices to evaluate it on prime powers, and on prime powers it does what you want it to do. Depending on, or at least for prime powers that are bigger, smaller than, it doesn't matter. Yeah, it should be fine then. Wait, so actually, can we just compute what it is for a prime power? It's like either this thing, if m is... For n equals p to the e, if p minus e to the 1 divides m, 0 else, right? Yeah, so we're fine. Yeah, I think that's basically what we're doing. I'm assuming I haven't screwed up the detail, but this should be fine. For previous one, I would have used Fourier. Yeah, I mean, that was also what we concluded. I was told there was an elementary solution and I couldn't find it, and after a while I was just like, I'm not doing this anymore. Okay, yeah, I think that's just it. And then when m is strictly less than n, then in particular, it can't be divisible by every prime power dividing n, so it's okay. Or this is really... Calculation right away. Interpret as a... Okay, I don't actually know what that word means. What is that? Oh. Wait, that's so tricky. I've never seen that before. Oh, the more you know. Wait, actually, I don't even... How does this finish? I mean, okay, I can see where it's trying to do. Okay, I don't see quite the math. I see that you wanna... I see that it's interpreting a volume. There's a normal Gramian and a magic Gramian. Wait, what? Okay, someone's gotta explain that to me. I don't think I know. I'm gonna write up the solution in the meantime. This LaTeX will need some cleanup. You know, I think it's actually faster if I just type it from scratch than to reformat the famous last words. v dots, v dots, v dots, v dots, d dots. Okay, so the idea is to subtract a combination of the first n-1 columns to wipe out all the non-diagonal entries in all the off-diagonal entry. Sorry, I meant rows. Off-diagonal. I don't use any particular formatter other than... So I have a white space trimmer, and I have a script that I wrote that automatically kills all the double dollar signs because I hate double dollar signs with a burning passion. That's it. I thought about... I don't know if there's a LaTeX formatter that I actually like. I thought about trying to write my own and tried it for like a couple hours and then gave up because I was just like, this is way too hard. So yeah, just the double dollar sign remover and the white space remover. The formula needed is the following. Okay, we have, so for, I don't know, sum d dividing n of frac n over d, GCD md is equal to 0 for m less than n, m equals n. Let me just write predicts. One, two, three, four, five. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I think really this is a case where if you show the examples, it's more important than writing the proof. I can fit 15 numbers in a line, right? Cos, to be fixed and define. Okay, so we do that. Oh my god, what happened to my iPad battery? Jesus Christ. Okay, we're definitely cleaning up after this. I thought I just charged this stupid thing. Oh yeah. Okay, so well, where was I? This function is multiplicative. So it suffices to have evaluated non-prime powers. Maybe I should use a letter that isn't M. How about R? I think it's I think R is a little more intuitive. However, we can check that f of R is equal, or sorry, f of p to the e is equal to p to the e minus p to the e minus 1 when p to the e divides n and 0 otherwise. That's a complete description of f. And f of n equals Vn is now clear. On the other hand, f of n equals 0 when R, because it's impossible that sorry, I screwed up. P to the e divides R. Yeah, it's kind of confusing because you want n to be the variable, but R is actually the fixed thing. N is greater than R. So really I should... Hang on. Okay, that's fine. Problem is then solved by induction. Yay! It's the yay. Is that good? So can someone explain what's going on with the gram matrix? I see that you want to take the vectors to be like the divisibility 1, 0 vector. I don't see how you compute the volume. Okay, let me... Okay. All right. Oops. Number theory. Do I call this number? This is probably number theory, right? Oh no. Oh, this is from the CMU MC book. What a great book. Come on. The only thing I don't like about it is the table of contents doesn't work on this thing for me. $141. Oh, so far. Heh. Wow, that is certainly I see. The matrix is upper triangular. Okay, that's impressive. Okay, well, that's that. Yeah, for those of you who are watching on Twitch, thanks for tuning in. Hope that was entertaining, kind of. Or, sorry, watching on YouTube. You're all watching on Twitch now. And yeah, for those of you on YouTube, see you all next time.